Hey, hello everyone, and welcome back to another video on ESP32. So, when it comes to Espressif, it offers different modules, or I can say the SOCs. So, we have ESP32C3, ESP32S3, ESP32C6, ESP32S2, and then we have ESP32E, ESP32H2 series. Then we have S3 series. So and there are few special modules as well, where you can see you have the dual antenna, and then you have H2 with the mini versions of it. So in this video, what we are going to cover basically is how you will be able to select all this part based on your requirement. I would like to thank Altium for sponsoring this video. To Altium Student Lab. So this is the new initiative started by Altium, where you can come and get access of all the curriculums on the PCB design side, ECAD fundamentals, and the best part of it, you will be getting a certificate also, and you can connect to the community where you have job opportunities at Altium, and also you can be a Altium designer where you can explore jobs on their community portal. So if I come to Expressive website and go under hardware product selector. So this is what the product selector tool look like. And if I show you here, right, let me minimize this. Okay, so we have all these basically the parameters where you can select and shortlist the parts. So if we talk, currently we have 283 items. Okay, let's go to product. So we have 48 SOCs available. Okay, and what do you mean by SOC, right? So if you see, these are all the SOCs. Okay, so these ICs directly when you are taking, this is the SOC. But when it comes to something like this which is being placed, okay, so this is what the module is. Okay, so let's go back to the selector page. So first of all, I will do, right, I'll go to status, and basically EOL is end of life, NRND is for not recommended for new design. So if I click over here, you can see there are 6 line items which are currently not recommended for new design. So maybe this will get obsolete in the coming days, or might be available in the secondary market, but it's advisable not to use this for any sort of a new design. When it comes to end of life, so these are basically towards the production end of life. That means after sometimes this let's say ESP32 S3 C3 exact part number which is there R84 FN4, so these will not be available. So simply what I will do, right, okay, let's see the sample also. So these are the ones which are currently in the sample phase. That means you can directly go and get samples for your hardware development. And the current status of this is basically not into production. That means if in case you materialize a design, okay, and you want the quantities in bulk, so you might not be able to get it because currently these are not into production. So the first filter which we are going to put is mass production. And if you see, um, I'll just uncheck SOC. Okay, so if you see, we have 190 line items which are currently there into mass production. Now let's go back to things one by one. So there are different modules that doesn't have a Wi-Fi. If you see Wi-Fi, you have NA over here, and it comes with Bluetooth 5.3, and these are basically the H2 series. Okay, so all these are H2 series. So just to remember, in H2 series you don't have Wi-Fi function available. And I'll leave other, I'll check other of these two things. Okay, so you have 170 line items. So as per our requirement, we need the Wi-Fi. When it comes to Bluetooth, I think Bluetooth 5.3 is what we are looking for. In terms of temperature, so it depends. If in case you are making something on automotive, okay, ideally you will go for something like -40 to 105, or -40 to 125 degrees centigrade. So I'll leave it as it is. Okay, in our project we are not going to use the Zigbee or the thread. Okay, but let it be. When it comes to product, we are actually looking for modules, so I'll select this. In terms of series, so these are all the series available. Okay, so as we saw, right, in H2 we don't have a Wi-Fi. Okay, so if in case you have specific series in mind, let's say C3, okay, so you have no line item under whatever we selected as of now available under C3. Let's select C6. So C6 we have 10 line items, okay, but I'll do one thing, I'll just remove this. So we have all the available SoC sorry modules available. Let's go to the status. Already I have selected mass production. In terms of core, I will leave it because whatever the application we are looking for, right, the single core will work. But if in case you are looking for a dual core, see nothing is available in dual core. Now let's change the setting. I'll just so the moment I put it BLE 5.0, right, you see we have got the modules which we are not showing under the dual core. Okay, if I have to see on single core, so I have 82 line items. If both I'm fine with, I have 107 line items. In terms of antenna, either you will have a PCB sort of an antenna. When I say PCB, so these are basically the PCB trace antenna. Let me show you over here. So if you see in this module, right, you have these antennas. Okay, so these are basically the PFC antenna. In some of the modules you will see let's say this one, right, so this is basically a SMA connector where you can put the external antenna or the patch antenna. So if you see, this is what IPEX means, okay, and then you have a shoulder pad. So shoulder pad, if I select, right, you have just one line item. So this is basically it will not have any sort of a connector over there. Sorry, it will not have any sort of a connector, just you will be having a shoulder pad. So what we are looking, right, we are looking for something with the PCB antenna. Okay, when it comes to package, so there are multiple packages available. Okay, and when it comes to QFN, okay, LGA, so just to uh, highlight one thing, right, so this is one of the best, I can say, portal which is available. So it's a basically a blog, and the blog name is embedded.ninja. And here if you come, right, here you will be able to see all the component packages. Okay, so we were looking for so this is the QFN package. Okay, so this is what the QFN package looks like. So when it comes to, so this is a QFN 16, that means you have all this 16 shoulder pads, okay, or the pins. When it comes to memory, you can basically change the SRAM, ROM, and flash size, PSRAM, RTCs if you need. And when it comes to peripherals, so peripherals are basically the communication lines, okay, or maybe you need something as a touch. Okay, so here you have ADC, DAC, touch, GPIO, UART, SPI, SDIO, host, slave, I2C, I2S, RMT, LED, PWM, MCP, PWM, pulse counter, USB. So what I am interested is like TWAI. So what TWAI is basically, it's a two wire automotive interface. If in case you want to learn more, right, so on the Espressif you can go to the peripheral APIs. Under that you'll be able to see this two wire automotive interface. So if you remember when we were there with the previous series, ESP32 room or ESP8266, in case you have to use a CAN communication, so you have to use something like a SPI where you can have CAN over SPI interface done. But the goodness with the updated modules that have come with from the Espressif is you can have at most of three TWA lines that can be used with the external trans receivers for CAN. You have JTAG, that then you have camera interface. Okay, then you have TOF. So this is how you can basically filter things. Okay, now let's see what all are here. Okay, so the moment you click any of this part, you will be able to see all the applications, features, memories, working voltage, everything as an interface, how many count of interfaces are there. Now you have to understand, like, most of the pins might overlap. That means pins are of multiple functionality. So whenever you are doing, so let's say 4 SPI interface as an example I'm saying, so you cannot use all of these at once. Maybe there will be a overlap in terms of the pins, so that you have to keep in mind. So if we talk about the headings over here, so we have the MPN, which is the manufacturing part number, you have the name, then this shows about the marketing status, which we saw, so these are all in mass production. The type is the modules, and then you have the Wi-Fi. This basically talks about Bluetooth 5.0, 5.3. Thread and Zigbee is what we are not using. In case you want to make something on the home automation or IP based system, I think Thread is what you will be going ahead with. In terms of temperature, this shows this part, what range it supports. In terms of general purpose input output pins, so 36 pins are available. If you go down, you have 22, you have 19, you have 14. Then comes flash, SRAM, ROM, PSRAM, frequency. So if in case you are not familiar or what all these means and how to select, so let's see one by one. So okay, so what is flash? So flash is basically the non volatile memory to store your program code and sometimes data. So what does non volatile means? Let's say you restarted the whole hardware, okay, still the memory, the data will be there, okay. So it will be persistent. It is nothing like, okay, it will the moment you shut down that whole maybe you have stored few details, or you have some variables defined over there, so that will not get erased basically. So why it matters, right? So bigger flash size, you can run larger and more complex program. So whatever the flash we are talking over here, right, we are talking about the external flash, okay. When it comes to SRAM, so SRAM is basically fast volatile memory, and when it says volatile memory, that means the moment you turn the MCU off or the SoC or the module off, the data will get erased. Okay, so these are basically used during the code execution, and where you can store your variables, stack, buffers, etc. And SRAM is so if you are going for a bigger SRAM, right, so it will give you a better performance for multitasking, data handling, or in case you are using any sort of a RTOS, real time operating system. And it is crucial for communication where heavy application, let's say image processing or AI interfaces are there. So let's see this. Okay, so if you see here, right, so I have all these SRAM. If you click over here, right, this will basically filter. So the maximum size which is available is 512 KB. Okay, sorry, yeah. Now, when it comes to ROM, which is a read-only memory, it is often used for storing bootloaders, factory firmwares, or secure libraries. So, in case on your module you have something as a custom bootloader written, okay, or the factory firmware or the factory bootloader, right? So that will be available there, and even you can put some secure libraries. So why it matters? Usually fixed by the chip vendor, which is Expressive in our case, and it is useful for having a secure boot or having a trusted firmware. The other one is PSRAM. Okay, so PSRAM, if you see, so these are basically your pseudo static RAM. So it's an external RAM that offers a larger memory size with dynamic RAM like cost. So this is basically a pseudo static RAM. So let's say if in case you have camera feeds, or you have large buffers, or you have some audio video, or you want to run some sort of a AI model. So if we talk about sorry, if we talk about this, right, so this is ESP32 S3, and if you come over here, you can say, you can see over here, right, yes, so it provides user with an offline AI voice assistant. It features far field voice interaction, continuous recognition, wake up interruption, and ability to recognize over 200 customizable command words. And Box3 can also be transformed into an online chatbot using advanced AIGC development platforms such as OpenAI. Okay, so if in case you want to make something as an assistant, right, where the way you have Alexa, let's say, and you say hello Alexa, similarly you can have your Jarvis version done, and you will have those capabilities, basically the offline voice assistant capabilities that is coming through the additional I can say additional processing power which comes through this external RAM. The other one is the frequency. Okay, so the clock speed of the processor of the microcontroller is what we say is the frequency. And let's say if you have a 1 megahertz frequency, okay, for a given SoC, right? So in that case, that means it can run 1 million operations, okay, per second. And 1 million operations, or I can say 1 million in interfaces it can run. Okay, so higher the frequency, it gives you more faster processing power and faster code execution. And it is basically used in real time systems, machine learning, encryption, or high speed communication tasks. And but it comes with some trade off. So if you, in case you are going for a higher power, higher frequency, right, the power consumption of that SoC is going to be high. So if in case you are making a low power system, so maybe you have to be very moderate. So don't design something which is overkill. So you cannot go just by the spec saying, okay, this looks fancy, let's go ahead with a higher frequency. You have to basically do a justice to your requirement or the end goal of your project. So what we saw over here, right, so this was S3. Okay, so let's see, I want to just see for S3. So if you see S3, right, so you have this PSRAM, you have 8 octal, okay, and then you have 16 octal. Then you have, so 0 basically means there is no PSRAM over here. Okay, and if you talk about the flash size, it is 16 MB flash size, 8 MB flash size. So what does this quad means, right? So this is basically quad SPI interface. Okay, maybe in the upcoming videos we'll be talking on this. So I hope flash, SRAM, ROM, PSRAM is clear with you, and also the frequency. So if you talk about the low frequency, so if you see here, the highest frequency is 240, and you have then 237. But if I uncheck this, let's see like what generally the frequency is. So you have 96, you have 120, 160, 240. So this is how your frequencies are. So when we talk about S3, right? Yep. So when we talk about S3, you see the frequency is higher. That means it gives it more processing power. Okay, more processing power to run that ML, machine learning. And also the PSRAM which is there, right, which I talked about, running some AI models and all. So if you see over here, you have PSRAM option, that is like 16 octa core with 32 MB of flash, okay, octal flash. So this is what makes it basically more powerful as a hardware. Okay, yeah. So this is all about how you can select. Okay, let's see some other things. So you have the size and dimension here, so these are all in mm. What does this MPQ or the SPQ means, right? So SPQ is the special package quantity. So this is the bare minimum, you can say, the unit of the tray that comes. Okay, and MOQ is the minimum order quantity. So sometimes you have to order a mix of this if in case you are going for a mass production. When it comes to pre-firmware, right, so this basically talks about if there is any pre-existing firmware that comes with the Espressif. So if you see, all these are no. This is the cheap revision versions that talks about, so there might be hardwares that keep on evolving, right? So you will have some versions over here. Now when it comes to voltage, you will see usually this modules powers from 2.3. Let me just unselect this. Okay, and if I show you over here, I think I'll remove some of the settings. I'm removing this. So if you see over here, you have 3.0 goes till 3.6, and then you have few modules that goes till 2.3 volts as well. Okay, so 2.3 to 3.6. So if you talk about ESP32 DODR2 D3, so this is basically the SoC. Okay, and the minimum voltage which it takes is 2.3 volts, and it goes upward of 3.6. So this is what you'll be able to have a selection in place. Now I want to select something on let's say C6, C3, and I need at least one CAN line. I need, so I'll highlight this. Now if you see, we have got all of these. And also I would like to hide basically the SOCs. So I will just select the modules. So I have 24 line items. So let me select few of these. Okay, so let me SRAM. Okay, okay. So let me select this and I'll click on compare. Okay, so I have to have, I'll select check this and I will check this as well. Okay, and the moment I click on this compare, so this is what it will open, right? So whatever we selected, it has come over here, and we are currently at the show same. So whatever the uh, basically uh, the differences between them is there, right? That is being currently shown. So if you see, in this one we have an option for thread, in this one we don't have an option for thread. uh, when it comes to SRAM, ROM, RTC RAM, SRAM. Okay, so this is what you have: 512 here, you have 400, ROM is 320, 384, SRAM is 16 KB, here you have 8 KB. In terms of GPIO, here you get 22 GPIOs, here you got 15 GPIOs. In terms of TWAI, if you see here, ESP32 C6 we have option for 2, here we have option for 1. So this is how you can compare. If in case, let's say I will add something else as well, so let me add ESP32. So here you will be able to see now ESP32 room N4 has come, and you will be able to compare. So this becomes basically your selection, and this whatever is showing, it's the differences. Okay, now if you click on show same, so this basically talks about what all parameters are same between these modules. Okay, so as a core, all are single core. In terms of frequency, if you see 240, 160, so whatever that has been highlighted red indicates the difference. In terms of status, so see this ESP32 S2, it's not recommended because it is end of line production, and these are currently into mass production. So this is how you will be able to select the parts. Let's go back. Okay. Mm, if I go to technical inquiries, yep, so if you go to technical inquiries, basically you can connect if you have any sort of a question. And in case you want to see how the whole thing works, right? So maybe I will show you. So if you can click over on product, so this is where you will get crisp details in terms of uh, the modules available. Okay, now let's see in terms of hardware design resource where we can get those. Okay, so if you go on technical documents, let's see. So this is where all your technical documents are there. In case you want the spec sheets of this, you can come and check over here. But we are interested in basically the hardware design guide. So these are basically the user guides. Okay, let's search for the hardware design guides. So if you come to support, right, you have this hardware and RF section. The moment you click over here, this is the page that opens. And if you scroll down, right, you have the hardware design guide. So you can click over here, and let's say we were searching for C6, right? So here you have, so here you have ESP32 C6 hardware design guide, and this is what the release date is. Okay, so if you click over here, you'll be directed to a documentation. Okay, and you can go with the schematic overview. So it will talk about what what things needs to be taken care in terms of a checklist for the schematic. Okay, so it will talk about the overview. So this is how the module is. Okay, and then you have the peripherals around it. So this is the reference schematic. It will talk about the power supply. If you click, so this is what the power supply is. That means here you can see the output current is not less than 500 milliamps. In case you want to select an LDO, okay, where you are converting the power from the USB or the external battery, okay, or maybe you are doing a step down. Okay, so in that case, you have to go with something where at least 500 milliamps of drive current is available. Okay, and this basically talks about as a digital power supply. So this pin number 5, pin number 28 are the digital power supply working in a range of 3.0 to 3.3, and it is recommended to connect an external zero point 0.1 microfarad decoupling capacitor. So in our videos, we have seen how to select this decoupling capacitor, right? But once you come to this documentation, okay, you will have all these recommendation given, okay. And if you see over here, it is recommended that user add zero point 0.1 microfarad and 1 microfarad close to the VD SPI pin. So if you see here VD SPI pin, okay, where it is, okay, so the VD SPI pin, right, you have zero point 0.1 microfarad. And if you talk about this pin, which is the VD SPI pin actually, so you have C16, C17. I'll just zoom the screen so that it's visible. Yeah. So it was been recommended at VD SPI pin to be placed zero point 0.1 microfarad and 1 microfarad. So you can see over here, we have those capacitors being done, and each of the supply pins, right, you have zero point 0.1 microfarad. When it comes to the analog power supply pins, these are the pins basically, and it again have a working voltage of this. And the inductor that needs to be placed is rated, preferably to be rated for 500 milliamps and above. So this is what you can see. So these are basically those pins, and you have a 2 nanofarad, and it talks about the rated current needs to be 500 milliamps at least. And this is what the decoupling capacitors are. Okay, so you can go through all of these documents in the upcoming videos, right? When we start creating the hardware, we'll be referring and we'll be circling back to this document again, and you'll be able to see things. And it covers almost all the topics when it comes to the power supply, the chip power and reset timing, flash, underclock speed, if in case you are using an external crystal, or you want to use a RTC clock, okay, so that also is there. Okay, so this is what the external RTC clock is. Then under RF you have, in case you want to make your own antenna, right, in that case, what needs to be taken care of. So this we are talking about when you are using the SoC directly. And in case you want to tune the antenna, okay, so how the tuning happens, and these are the capacitors, right? So these capacitors have, and the inductors will have some values, and they have suggested few part numbers as well, okay. In terms of UART, it is recommended to connect 499 ohm series resistor to the UT0 line to suppress basically the 8 megahertz harmonics, if in case you are having, okay. So these are the design guides, I think would be very helpful for you to go and have a look based on whatever the chipset you are selecting. When it comes to PCB layout, it will recommend in terms of how that layout needs to be there. Layer 1 should be having signal, layer 2 as a ground, layer 3 as the ground plane, which can have an isolation for RF and crystal, then the bottom layer for signal trace again. So for a two layer, you have the top and bottom strategy, where on the single, on the layer 1 you have the signal trace and components. On the layer 2 you have basically the components, where the traces needs to be very minimum, okay, so that can be put down. So this is very user friendly, I would say, or something as a beginner friendly, where you can come, spend some time, understand how these design things are there. Now coming to, again, back to this, right? So we saw basically how you can have all this part selection, how you can go and compare the two different modules. So based on your use case, you have to define what sort of a module you are looking for. And if you see all these companies, right, so they make all these modules because it solves for a different purpose. Maybe down the line we'll be working with S3, okay, because I'm very uh, happy to see like we have something like this that can be integrated with uh, open AI, okay, and you can have some voice conversation done. So guys, this is what was all about video. I hope you like this video. If in case you have any suggestion or anything which you want to discuss, please do comment in the video. Like this video, share it to your friends. Thanks for watching. Thank you.